Hey everyone, so this is Polka Dollar, a cross-chain volatility aware lending protocol that turns DOT into a synthetic dollar. In simple terms, we can say a collateralized debt protocol on Polka.hub. User deposit DOT and borrow a dollar peg token called PUSD, which is an ERC token. The protocol decides how much collateral you need based on market volatility. And the calculation happens inside a Rust contract on Polka VM, and which is called directly from the solidity in the same transaction. We also ran a C++ contract on Polka VM that scores position stability across 3 dimensions. So let's get started. The dashboard reads live from contracts on Passio Asset Hub testnet. The dot price, the real price from CoinGecko, is pushed on chain by our oracle every 60 seconds. And the risk regime, which is low, this is the output of the Rust EWMA contract. By the calculation variance, it looked at the recent price history and computed the variance and classified it as low volatility, which means 130% of collateral ratio. This gauge value reads directly from the Rust contract's assets risk function. The needle, the volatility number, the ratio, all are from the Polka VM. And as I mentioned earlier, we also use a C++ stability analyzer for safer borrowing with real-time protection, which shows the status flag whether it's stable or unstable. And we have the dot price history for 30 days and as well as the collateral ratio for 30 days below as graphs. So coming to our main vault page, as you can see, I currently have 10.74 DOT deposited with 3.10 PUSD depth, and the health factor is 5.30, which is very safe. So let me deposit more and mint. So I'm type 0.5 in deposit field, and you need to sign the transaction, which this calls the vault dot deposit with native dot attached. And yeah, so the transaction has been successful, and let's go. And now the collateral is 11.24 DOT, as you can see. And yeah, so I'm coming to the mint field. I'm currently minting 0.5 PUSD here, and let's see what happens inside the single transaction. And as usual, we need to sign the transaction. Well, after minting, 4 things happened here. First, the vault calls risk engine caller, that solidity calling the Rust contract through the palette review. The Rust contract computes EWMA variant from the stored price history from CoinGecko API and returns regime value 0, and the ratio is 130%, which is low. On second, the vault calls a stability analyzer that's already calling the C++ contract. It scores my position across the collateralization level and the volatility and the ratio buffer, and which returns a stability flag, and currently it is stale. Coming to the third point, the vault reads the price from price feed and checks it's not stale, must be within 30 minutes. And the last fourth point, the vault does the math. My collateral time price must cover my debt ratio, and if it passes, the PUSD tokens are minted to my address, and that's what it happened. So we can see the change in the collateral deposit, which is 11.24 DOT right now, and let's burn some tokens. And so now I repay some debt and withdraw the collateral. So I'm doing some 0.25 PUSD, and now the vault destroyed this token and reduced my debt, and we need to sign the transaction. And yeah, so we can also view our transaction here by navigating to the transaction hash. And yeah, so it has interacted with my contract, and the status and the method is burn. Now I'm withdrawing a 0.1 DOT, and yeah, so the vault checks through the Rust engine again that my remaining collateral will still covers my debt at the current ratio. So yeah, the transaction is successful and it came back to 11.14 DOT, and we can view the transaction on chain here. Now that my collateral is 11.14 DOT, the position is healthy. So we can view all the summary of the transaction, the deposit, mint, burn, and withdraw. Coming to our one of the interesting feature, which is the bridge, which uses the XCM precompile on Polka.hub. Here we have the set of the parachains for the destination chain, and also a scale encoded destination and a scale encoded XCM message is passed. So the message contains 3 XCM version 4 instruction. The first one is withdraw assets, second is buy execution and deposit assets, and these are encoded in TypeScript using polka.types and passed as a raw bytes to our XCM transfer contract. So I use my secondary wallet for my destination wallet, and we have to wait for some time for the on-chain confirmation. And once it's done, yeah, so we got the on-chain transaction, which the precompile accepted the message, and the transaction is confirmed on-chain. And we can also view it in the block explorer, and yeah, so it has interacted with our contract and it is a success. And also on mainnet, once PUSD is registered on Hydration or any other parachain, With the exact call, the same bytes, same pre-compile, delivered assets cross-chain. Only the destination bytes change. And we have the risk monitor tab here, which have the variance formula, and we have the current regime, and we also have two graphs here for the volatility over time and the dot price plus ratio overlay. And that's how it works. And coming to the most important part, and you may wonder not that what happens when volatility spikes. Yes, so I'm going to simulate a market crash by pushing the volatility prices to the oracle, and this is the on-chain confirmation, and now it's the regime is currently extreme, and the risk engine has been calculated, and watch the gauge. So I'm going to copy my second account to pay off the debt. So I'm gonna, yeah, so hit this button, and as you can see, this position is liquidatable because the health factor is zero point 0.9, which is lower than 0.2, and I have to hit the liquidate button and wait for some time. And yeah, so in my main account paid off the 0.23 BUSD debt and received the 0.220 dot collateral plus a 5% boost, and now the position is closed, and the rust engine detected the volatility and the ratio increased. And yeah, and so that's all from my side, and thank you for staying this long. Thank you so much.